Assalamu alaikum. My name is Sidra Ijaz and my roll number is 16T39. This is the fifth lecture of DSP in which I am discussing the example of time shifting, time scaling and mirror operation. For example, if we have these three operations in a single example or in a single system, then what should we do or what step should we perform first to get our output? That is, you can see in this example, y of n is equal to x of minus 2n plus 3. We have time shifting and this plus 3, we have time scaling this 2, and we have time flipping of the system, that is this minus it's showing. So the first step we do will be time shifting, the second step done will be flipping of the system, and the third step is time scaling. In time scaling we have two types of basically scaling: amplitude scaling or index scaling. If we write 2x of n, then this is amplitude scaling, and if we write x of 2n, then this is index scaling. In index scaling we have two types: either compression of the signal is done or expansion of the signal is done. So first of all, for this signal we will shift the signal, that is u of n. I have made it equal to u of n. U of n is equal to x of n plus 3. I have ignored other time scaling and flipping of the system. Then this output u of n, if I flipped it u of minus n, then this will be equal to another output w of n, and this w of n, if it is compressed by a factor of 2, that is w of 2n, then this will be equal to the actual output of the system after performing these three basic functions of shifting, scaling and flipping. So first of all, as I have x of n is equal to this, I have 0 index at minus 1. So first of all, performing this shifting operation, x of n plus 3 is equal to u of n. So first of all I will put n is equal to minus 5, then n is equal to minus 4, then n is equal to minus 3. N is equal to minus 5, I'll put this here, n is equal to minus 5, 3 minus 5 is minus 2, x of minus 2. We know that this is at 0 index, this is at minus 1, and this is at minus 2. This is at 1, 2, 3, 4 and 5th index. So x of minus 2 is 1, so answer is 1. Similarly, at u of minus 4, x of minus 4 plus 3, that is x of minus 1, and at x of minus 1 we have 2, so this is equal to 2. Similarly, by putting different values of n, I have got my output u of n at this, and as we see that u of 0 is equal to 1, so now my index is shifted to this place, and I have drawn it like this, and this is my axis origin, and at origin I have one value. So this is my output. Now the next step was the flipping of the system. W of n is equal to u of minus n, so these values will be shifted. Now that first of all my system was 0 1 2 minus 1 2 0 1 1 3. Now my system will be 3 1 1 0 2 minus 1 2 1 and 0, and the index will be shifted from this point to now this point, and the output signal will be like this. Now the next step is scaling of the signal by a factor of 2. So first of all, putting y is equal to n is equal to minus 2, x of 2 minus 2 is x of minus 4, and we don't have any value at minus 4 in our output of the previous section, so x of minus 4 is equal to 0. Similarly, putting the values, I will get my output y of n is equal to this, and my index is now shifted as y of 0 is equal to 1, so my index is shifted at this point, and I have drawn the output as this. Here is my origin. Now the next topic is representation of the signal through impulse signals. Linear time invariant system. This is the main property which is intensively used in digital signal processing and in many applications. Linear time invariant systems can be completely described by their unit impulse response. That is, if we have a system, we can sum those the component of those signals by making them impulse signals. That is, we can write x of n is equal to x of k into sigma n minus k. This sigma n minus k is the shifted impulse, and this x of k is the amplitude of that original signal. For example, if the signal value is 2 at plus 1. Value is 2 at plus 1. So this plus 1, as we know that sigma signal or impulse signal is only 1 at 0. So if I shift that 0.2 to 1 by sigma of n minus 1, now I have obtained this point, that is the signal value at 2. Now if I multiply this sigma n minus 1 with 2, so I will get this condition, that is value is 2 at plus 1, and I have represented it through a impulse signal. Similarly, if I have an input, for example, I am taking an example, x of n is 2, 3 and minus 1. This 3 is the index point, that is it is at 0, this is at 1, and this is at minus 1. So this minus 1 point can be represented through an impulse signal as delta n plus 1, sigma n plus 1, and this 0 point can be expressed at delta as sigma n, and this minus 1 point at plus 1 can be represented as sigma n minus 1. So we can write x of n as 2 sigma n plus 1 plus 3 sigma n plus minus 1 sigma n minus 1, and after solving this we will get a required result, that is x of n 3 at 0, 2 at minus 1 and minus 1 at 1. And also I have drawn these pictures. At sigma n plus 1 is this, as we know that n plus 1 mean n plus 1 is equal to 0 and n is equal to minus 1. So I have a value of minus 1. At minus 1 the value is the impulse response. We know that it has a unit amplitude, so unit amplitude when multiplied by 2 is 2, so we get a minus 1, 2 at minus 1. Similarly, sigma of n means we are at 0 point and the amplitude is multiplied by 3, so the answer is 3. Similarly, this point is at 1 and the signal amplitude is multiplied by minus 1, so the answer is minus 1. And now if all these are combined, then we will get after adding we will get the output function as this, which is similarly equal to x of n is equal to 2, 3 minus 1, 3 at 0. We can see that 3 is at 0, 2 at minus 1 and minus 1 at 1. Now we can find out any impulse response of the signal for any kind of input signal. First of all, discussing what is an impulse response. Impulse response is such a response due to the impulse input, that is sigma of n with zero initial conditions. Zero initial conditions mean before applying input there was nothing in the system, and this is also called as relaxed conditions. And the impulse response can be also represented as sigma of n to the system, and the system must be linear time invariant system, and h of n at the output. For example, I have a question: find impulse response of y of n as x of n minus x of n minus 1. Now if x of n is the same, 2, 3 and minus 1, this is the index point, that is 3 at 0, 1 minus 1 at 1 and 2 at minus 1. And x of n minus 1, that is it is the delayed version of this signal. So now this 3 is shifted, this index point, that is 0, is shifted at this, and 3 and minus 1 values, amplitude values will be same. So what we do in impulse response is that we change this x of n into sigma of n, that is into impulse response. And as we know that sigma of n is 0 for n is equal to 0 and 1 at n is for n is equal to 0 and 0 otherwise. So we can write y of n is equal to or this y of n can be written as h of n. This is basically the impulse response is shown by h of n. Sigma of n minus sigma of n minus 1. First of all, we'll put n is equal to 0, so sigma of 0 minus sigma of 0 minus 1 is minus 1, and as we know that is impulse response is only 1 at sigma of 0, so this is 1, and at minus 1 sigma response is 0, so it is 0, 1 minus 0 is 1. Similarly, by putting different values of n, I have got the response of this signal as h of n is equal to 1, minus 1 and 0, and the index is now shifted to 0.1. Similarly, now another system is y of n is equal to x of n minus 2xn minus 1 plus xn plus 2, and another system is y of n is equal to 0.5 y of n minus 1 plus x of n. First of all, I will discuss this system. I have to find its impulse response, so I can write h of n is equal to sigma of n minus 2 sigma n minus 1 plus sigma n plus 2. Now I will put different values of n, 0, 1, 2, 3, and minus 1 and minus 2 in these systems. That is, first of all, if I take in one of its value, then if I take n is equal to 1, then h of 1 means y of n. Y of 1 means the output of the system. You can write this or you can write this. And at this n, I'll put in n is equal to 1, and n is equal to 1, 1 minus 1 is 0, that is sigma of 0, and 2 plus 1 is 3, sigma of 3. Sigma of 3 is 0, as we know that impulse response is only 1 at 0. So this is 0 and this is 0 and this is 1, and 1 is multiplied by minus 2 is minus 2. So the answer we got is minus 2. So by putting different values of n, I have got my impulse response as h of n 1, 0, 1 and minus 2 and 0. And as I know that I have got value at 0, n is equal to 0, 1. So now my index is shifted to this point. Now the second system was h of n is equal to, or y of n is equal to 0.5 h of n minus 1 plus x of n, or the original signal was y of n is equal to 0.5 y of n minus 1 plus x of n. I have to find its impulse response, and we are assuming we know that this signal in this signal there is actually a causal system, because its values depending in its past values. The current value of the output is depending on the past values of the output, and we are assuming the relaxed conditions. Relaxed condition mean that the signal was 0 before, the signal was 0 and there was nothing before the input applies, that is, it was 0 before the starting of the signal. So I have put h of n in place of y of n, and this was h of n minus 1, and I have replaced x of n with sigma of n, because we know that for impulse response we put our input equal to sigma function. I can write it as 0.5 h of n minus 1 plus sigma of n. Now I will put different values of n, and a 0 and 1 and 2, and discussing this 0.5 h of, as n is 0, 0 minus 1 is minus 1, h of minus 1 plus sigma of 0, n is equal to 0. I know that sigma of 0 is 1, but h of minus 1 means the system's response or system's output at minus 1, and as I have said that we have assumed relaxed conditions, so system's response before 0 was 0, so this h of minus 1 is 0, and 0.5 multiplied by 0 is 0, so the answer is 1. Similarly, if I discuss h of 1, and I have put n is equal to 1, at this n is equal to 1, 1 minus 1 is 0, so h of 0 plus sigma of 1 will be 0, and h of 0, I have calculated h of 0 is equal to 1, so putting here that value, and that multiplied by 0.5 is 0.5. Similarly for h of 2, here will be h of 1, and h of 1 value is 0.5, so 0.5 multiplied by 0.5 is 0.25, and sigma of 2 is equal to 0. So I got my response as 1, 0.5, 0.25, 0.65, and so on. And at last we have a new concept of finite systems and infinite system. Finite system is such a system with finite response, and infinite system is such a system with an infinite response. As you can see here, this system will give us an infinite response as we will be increasing the values of n. So this is all about lecture 5.